In problems 13 through 15, some of these are similar to the ones you just did. We are asked to find the value of x to the nearest 10th, and we're going to take a look at problem 13 together, and then you will try 14 and 15. And 15 is pretty easy. I think 14 might be challenging, but all right. So if we look at problem 13, we are looking for this value of x, and so we have a chord, a radius, and then we have this line from the center of our circle that intersects the chord at a 90-degree angle, so it's perpendicular to the chord. And this is a lot like that last problem where if this line intersects the chord at a right angle, we really end up with two congruent right triangles. And like we said in the problem above, we could prove that using the hypotenuse-like theorem. So what you want to do is, I'm going to draw this triangle separate outside of the circle. So here's my right triangle. We said this is x that you're solving for. We're told this radius is 5. And then we know the entire chord is 8. So since the entire chord is 8, this segment is half of the chord, so it's 4. So now we can do the Pythagorean theorem to find x. You might recognize this as one of our special right triangles though. So we could say x squared plus 4 squared equals 5 squared. So that's going to become x squared plus 16 equals 25. When I subtract 16 from both sides, I get x squared equals 9. And when I take the square root, x is equal to 3. So this is what we call a 3, 4, 5 right triangle. So you can use the Pythagorean theorem to solve for problems like this. You're going to try number 14 in your groups, but I just want to offer you a hint on number 14, is that when you create this right triangle, don't make this entire side of it x. Like that's going to not help you because this entire chord is x. So I might choose another variable. You could think of this as just being half of x. I might even let that part equal y and then say to myself, well, whenever I figure out what y is, it's going to take 2y to make that x. Because if you use this right triangle to find that, you're only finding half of the chord, not the entire chord. All right, I'm sure you can take it from there. Good luck.